Hello guys, today we will discuss the series motor and their characteristics. So series motor, so this series motor field flux is depend on armature current. Field flux is depend on armature current IA, and can be assumed to be proportional to armature current in the unsaturated region of magnetization characteristics then pi equal to kf into ia, so I can write as kaf, constant kaf equal to ka into kf. So as you know, back EMF in series motor is Eb equal to Ka pi into omega, and from this I can write as Eb equal to Ka into Kf into Ia into omega. As you know, pi equal to Kf into Ia, so I have replaced pi as Kf into Ia. So Eb I can write as Kf I can write as Kf, no? So Eb equal to Kf into omega. But as you know, torque equal to Ka pi into Ia. So from this I can write as torque equal to Ka into Kf into Ia into Ia. So I can write as torque equal to Kf Ia square. From this, if I subject the Ia value equal to T by Kf I can write as Kf, no? So T by Kf under root. This is the Ia value. So I can write here Kf Ia square equal to T. So Kf into Ia square equal to T. From that, Ia value equal to T by Kaf. This is the value. So I can substitute here Ea equal to terminal voltage, Ea equal to back EMF plus Ia Ra. So from this I can write as omega value equal to Ea by Kaf into Ia minus Ia Ra by Kaf into Ia. So from this the Ia value will be cancelled. The omega value equal to Ea by Kaf into Ia minus Ra by Kf. From this I can substitute the Ia value. As you know, Ia value is T by Kf, no? So I can substitute this value here. Omega equal to Ea by kf into under root of t by kf minus ra by kf. So from this the root of kf and kf will be cancelled. I can write as omega equal to Ea by under root of kf. So I can write once again here, if I take this value kf here, root of kf into under root of kf into under root of t by kf. So 1 kf will be get cancelled, minus ra by kf. So I can write omega value equal to Ea by root of kf into under root of t minus ra by kf, ra by kf. So I can write this value as omega rotor speed. This is the equation for series motor. And speed torque characteristics. The speed torque characteristics of separately excited motor are the speed and torque characteristics, speed and torque characteristics of separate series motor is, we can take this as inverse hyperbola characteristics, speed and torque. This is inverse hyperbola characteristics. It can represent like this, and this is rated speed and rated torque. So these characteristics we will represent as inverse hyperbola characteristics. Inverse hyperbola characteristics. Inverse hyperbola characteristics. So this is the speed torque characteristics of series motor, and this is the rotor speed Ea by root of kf into root t minus ra by kf. This is the speed of series motor. So we have found out the speed torque characteristics as well as speed of series motor. Thank you guys. We will meet in next class.